The nearest star beyond our sun is not a mystery. It's not hidden behind dust or buried in some unreachable corner of the galaxy. It's right there, quiet, steady, almost modest. On a clear night, you could point to the sky and say, that's the direction, that's the neighborhood, that's the next shore. And that is what makes it unbearable. Because Proxima Centauri is close only in the way a mountaintop is close when you're standing at sea level with no roads, no oxygen, and no time. In cosmic terms, it's practically next door, just over 4 light-years away. But in human terms, it may as well be on the other side of eternity. What changed everything was not the star itself, but what we found circling it. A planet, Proxima b, a world roughly Earth-sized, sitting in the star's habitable zone, where temperatures might allow liquid water to exist. Not a promise of life, not a second Earth, but something far more dangerous to the human mind possibility. The idea that a place like ours could exist around the nearest star turns Proxima from a dot into a destination, from astronomy into strategy. And once a destination exists, the question becomes a kind of gravitational force. It bends every dream, every invention, every future timeline toward it. Can we get there? The short answer is no. Not with anything we can build today. We have not sent a human beyond the moon, 384,000 kilometers away, a distance so small on a cosmic map, it's almost embarrassing. We've sent machines farther, yes. We've thrown metal messengers into the dark Voyager 1, launched in 1977. Still moving, still surviving, still speaking in a faint robotic whisper, 17 kilometers per second. That sounds like a triumph until you translate it into reality. At that speed, a journey to Proxima Centauri would take roughly 76,000 years, longer than recorded history, longer than civilization has existed. The probe would leave Earth as a relic of one species and arrive as a fossil of a forgotten world. To make this trip fit inside a human life, we would need a different kind of motion. Not faster by degrees, faster by orders of magnitude. Thousands of kilometers per second at the absolute minimum, tens of thousands, if we want the voyage to feel like something a living generation could witness. And that's when the paradox becomes clear. We can see the shore. We can even see a world on it. But the ocean between stars is not water. It is distance itself, cold, empty, indifferent. And right now it does not care what we want. So the story of Proxima Centauri is not really about a star. It's about a species staring at the nearest door out of its cradle and realizing the door is locked by physics. To understand why Proxima Centauri feels so close and why it still defeats us, you have to shrink the universe into something your instincts can hold. The moon is far enough to humble a rocket, 384,000 kilometers, a number that sounds enormous until you realize we can cross it in days. It is a trip that still fits inside a human attention span. Now widen the map. Mars at its closest is tens of millions of kilometers away. Months with today's propulsion, and even then, only with perfect timing. The outer planets stretch that to years. And yet all of this, every world we've ever touched, every probe we've ever sent, every human footprint we've ever left, is still inside the shallow coastal waters of a single star system. Because the scale changes when you leave the sunday. A light year is not a poetic phrase. It is a distance so large, it breaks the mind's ability to picture travel. Light itself, nature's fastest messenger, needs a full year to cross it. Proxima Centauri is more than 4 of those years away. Over 40 trillion kilometers, a gap so wide that our entire solar system could drift inside it like dust in a cathedral. And still we tried. Voyager 1 is the farthest object humanity has ever launched. It is the sharpest spear we have thrown into the void. Since 1977, it has been moving at about 17 kilometers per second, roughly 540 million kilometers per year. It has crossed the orbits of planets, skimmed the edge of the sun's influence, and entered the thin, strange frontier we call interstellar space. But here is the brutal math. At that speed, to reach Proxima Centauri would take around 76,000 years. And Voyager isn't even going there. It's heading elsewhere, drifting through darkness, like a message in a bottle that will never find the shore you intended. So if we want a voyage that means anything to living humans, the target shifts. Not can we reach it eventually, but can we reach it in time to matter? Even a century is already a compromise. At roughly 10,000 kilometers per second, you could arrive in about 130 years. Fast enough to be history, but not fast enough to be memory. To bring it into the span of a single lifetime, you're talking about 50 years or less, tens of thousands of kilometers per second, a significant fraction of the speed of light, and that is the moment traditional rocketry collapses. Chemical propulsion is beautiful, and it's what opens space to us, but it is chained to its own exhaust. Every kilogram of fuel you carry requires more fuel to push it, which requires more fuel to push that fuel, until the spacecraft becomes an absurdity, a mountain made of propellant. To reach even 1% of light speed using chemical rockets, the mass ratio becomes grotesque, so extreme that for each kilogram of payload, the required fuel would be measured not in tanks, not in oceans, but in worlds. A spacecraft with the mass of planets. A rocket equation that doesn't negotiate. So the problem is not courage, it's not imagination, it's not even engineering talent. It's that the distance to Proxima Centauri is a test of physics itself. And if we want to pass that test, we have to stop thinking like we're building better rockets and start thinking like we're trying to bend the rules of motion. So humanity does what it always does when the old tools fail. We start inventing new ones. At first, the ideas are almost comforting because they are real. They exist. They have flown. Ion engines and plasma thrusters whispering streams of charged particles into space, trading brute force for elegance. They don't burn fuel like fire. They sip it. They can thrust for months, even years, slowly building speed in the silence. In the solar system, that patience is power. But between stars, patience becomes a prison. Even with continuous thrust, even with high efficiency, these engines are still tethered to the same limitation. The amount of propellant you can carry and the modest acceleration you can sustain. On an interstellar journey that translates into the same bitter conclusion, tens of thousands of years. Not a voyage, a geological event. Then comes nuclear thermal propulsion reactors, heating a propellant, blasting it out at speeds chemical rockets can't reach. A genuine leap. The kind of technology that could shrink Mars missions, reshape exploration, and make the solar system feel smaller. But Proxima does not care about leaps measured in percentages. It demands orders of magnitude. Even the best nuclear thermal concepts still leave you facing interstellar travel times, so long they might as well be myths 40,000 years and more. Faster than Voyager, yes, but still slow enough that continents would rise and fall while your spacecraft coasts through emptiness. So we look for something more radical, a machine that tries to turn the vacuum itself into a road. VASIMR variable specific impulse magnetoplasma rocket sounds like a password from the future, but it's a serious idea born from serious physics. A plasma engine that uses magnetic fields to heat and expel propellant at different efficiencies depending on the mission. Built around a promise that feels intoxicating, continuous acceleration strong enough to make deep space travel inside our solar system feel almost human. In theory, it could cut a mission to Mars from 18 months to just 39 days. 39 days. The kind of number that makes you feel for a moment like the universe is starting to give way. But then you extend that trajectory outward toward Proxima Centauri, and the dream fractures. Because even with performance that would revolutionize everything nearby, the interstellar gulf remains. The travel time becomes thousands of years, around 2,200, 1,000 lifetimes. A civilization's entire arc just to reach the nearest star. And that's the psychological trap of these almost solutions. They are incredible, but they still live inside the framework of gradualism. They assume we can climb to the stars with better stairs. But interstellar space is not a staircase. It is a cliff. To reach Proxima Centauri in a time a living human can care about, we need propulsion that does not just improve efficiency. We need propulsion that changes the definition of what a spacecraft is. And in that moment, the story turns darker, because the technologies that might actually push us across that abyss are the ones that sound like madness. Ideas that smell like apocalypse, that borrow their strength from violence, from immense power, from forces we usually reserve for the end of worlds. The closer we get to the stars, the more we realize the obstacle isn't distance. It's what we're willing to become, to defeat it. There is a point where engineering stops feeling like invention and starts feeling like confession. Because to cross interstellar space, you eventually find yourself reaching for the most brutal energy source. A young civilization knows how to control the atom. In the late 1950 seconds and 1960 seconds, when the world was drunk on both rockets and nuclear fire, a proposal emerged that was terrifyingly straightforward. Project Orion. Not a sleek engine, not a gentle flame. A spacecraft propelled by nuclear explosions, detonated behind it one after another like footsteps made of suns. The concept is almost obscene in its simplicity. You build a massive ship. You attach a gigantic pusher plate to its rear, mounted on shock absorbers. And you throw bombs out the back. Each detonation slams into the plate. The shock absorbers compress, the force transfers, and the ship surges forward. It is not a rocket. It is controlled catastrophe. On paper, it works. In fact, it works disturbingly well. With fission devices, you could reach speeds far beyond chemical propulsion. With fusion, far more energetic. Orion begins to look like one of the few methods capable of pushing a large payload to a meaningful fraction of light speed. But then, the cost arrives. And it isn't just financial. To accelerate a spacecraft toward Proxima Centauri, you'd need on the order of hundreds of thousands of explosions. The ship itself would be colossal, hundreds of thousands of tons, with a pusher plate the size of a building 100 meters across. It would be less like a vehicle and more like a floating city bolted to a shield. And even then, the trip is still long, roughly 150 years, which is where the idea mutates into something else entirely. Because a 150-year mission is not a journey you take. It is a society you build, a generation ship, a vessel where people are born under artificial skies, live entire lives inside metal corridors, and die knowing they will never see the destination with their own eyes. The mission continues not because the original crew survives, but because the mission becomes their civilization's religion, an inherited purpose passed down like a sacred story. And here the unknown deepens. How do you design a culture that can survive enclosed for centuries without collapsing into conflict, despair, or apathy? How do you maintain knowledge across generations without corruption or loss? How do you ensure the ship doesn't become a drifting tomb because the descendants simply decide the stars are not worth it? Even if Orion were physically possible, it demands something our species has rarely demonstrated for long: stability. And then there is the moral gravity, the political reality, the problem of launching a nuclear bomb-powered spacecraft from a living planet, the fallout, the treaties, the fear, the fact that Orion is the kind of project that cannot be built quietly. It would announce itself to the world not as exploration but as power. So Orion sits in that uneasy category of feasible in theory, monstrous in practice. A door that opens, but only if you're willing to walk through carrying fire. And if that is what it takes to reach Proxima Centauri, the question becomes sharper than any equation. Are we trying to reach another star? Or are we just learning new ways to weaponize our own ambition? If nuclear pulse propulsion is the loudest way to reach the stars, then sails are the opposite. Silent, bloodless, almost elegant. A sail does not push against air, it pushes against light. Not the solar wind particles are too weak to matter at scale, but the pressure of photons themselves. Every beam of sunlight carries momentum. Tiny, yes, but in space where there is no friction and time is the true engine, tiny can become destiny. We have already tested this idea. Small sails have flown. The physics is real. The problem is that sunlight fades fast, and even a perfect sail accelerates slowly. To make it work, you'd have to unfurl something enormous and impossibly light, then dive close to the sun, where the radiation is strongest, close enough that your materials must survive temperatures that feel like the edge of a furnace. Even then, a solar sail alone still leaves you with a journey measured in millennia. So the future bends toward a more audacious thought. What if the sun isn't your engine at all? What if Earth builds one? A laser sail, also called a photonic sail, takes the same principle and replaces sunlight with a concentrated, relentless beam. A phased array of powerful lasers positioned on Earth or in orbit fires at a thin, reflective sail attached to a tiny spacecraft. The spacecraft carries almost no propellant because it doesn't need it. The energy stays behind. The vehicle becomes more like a bullet than a ship. And suddenly the numbers change from impossible to merely insane. With a sufficiently powerful laser system, a gram-to-kilogram scale probe could be pushed to around 20% of the speed of light, about 60,000 kilometers per second. At that velocity, the nearest star is no longer a myth of deep time. It becomes a destination within decades. This is the promise behind Breakthrough Starshot, not one grand ship but a swarm. Thousands of microprobes, StarChips each only centimeters across, carried to space by a mothership then fired outward on beams of light. Many would die. They would be shredded by interstellar dust, blinded by radiation lost to chance. But a swarm doesn't need perfection. It needs survivors. If even a handful reach Proxima Centauri in 20 to 30 years, they could race through its system and glimpse Proxima b, its curve, its color, perhaps the thin signature of an atmosphere. And then comes the loneliest part, the message home. Even after arrival, Earth must wait 4 more years for the light-speed Echo to return. A mission where the most precious cargo is not people, not minerals, not flags, but information. A few grams of technology, trying to deliver the first close-up truth of another world. Not within 1,000 years, not within mythology, but within the living memory of this century. And if that happens, if a signal returns from the Proxima system, something in us will break open. Because for all our talk of rockets and lasers and numbers, the real barrier has never been distance alone. It has been psychology. The quiet certainty that the stars are decoration, that they are unreachable, that they belong to gods, not engineers. Proxima Centauri challenges that certainty in the most intimate way possible. It is close enough to haunt us, close enough that we can name its planet, estimate its mass, calculate its orbit, and argue about its atmosphere like it's a place we might someday stand. But it is also far enough to expose the limits of our current self. To reach it, we have to become a species that can think in decades without losing interest. A species that can build infrastructure on a planetary scale, laser arrays, precision optics, energy systems that rival nations simply to send a handful of tiny machines into the abyss. We have to accept missions where the launch team might retire before the first data arrives. Where success is not a triumph you witness, but a gift you leave behind. That is what makes Starshot and every serious interstellar concept so revealing. It strips exploration of its romance and replaces it with discipline. It asks whether our civilization can hold a single thread of purpose without snapping under politics, distraction, fear, or fatigue. And then there's the deeper truth, the one we avoid because it makes everything feel fragile. Staying home is not safety. A single planet is a single point of failure. A thin atmosphere, a narrow temperature range, a web of ecosystems so delicately balanced that 1 century of mistakes can shake it. If we want to survive not just as a culture but as a lineage, if we want to persist through the long night of cosmic time, then we have to learn to live beyond one world. Not because the universe owes us a second home, but because the universe does not care if we disappear. This is why Proxima b matters, even if it's sterile, even if it's scorched by flares, even if its skies are poison and its surface is a desert of stone. The value of reaching it is not finding aliens. It is proving that we can cross the void at all, that we can take a mind born in gravity on a wet rock orbiting a small star and extend its reach to another sun. And perhaps that is the most unsettling part. The moment we are capable of visiting other stars, we will no longer be the same species that first looked up and wondered. We will have matured into something else wise enough to coordinate, patient enough to wait, and powerful enough to turn light into propulsion. Because going to the stars isn't a single mission, it's a change of state. A transformation from a civilization that studies the universe to a civilization that enters it. So the real question Proxima Centauri asks is not, can we get there? It's this. When the door finally opens, when the first whisper from another star reaches our world, will we be the kind of civilization that deserves to step through?